then we very quickly will be able to show what we want to show. Okay. In part 2, we want to calculate the value of x for which z has a stationary value and then show that this value of x makes z a minimum. Okay, so what we need to do is to differentiate. Okay, first we want to find the value of x that makes z as a stationary value. So we consider this equation that we have just shown. Okay, and then we do our differentiation dz over dx. So dz over dx is equals to 1 minus 4 over x squared. Okay, what do we need to do next? What should we do next? After we differentiate. Do derivative test.
Make it equal to 0.
Make it equal to 0 first, right? Okay, before we jump into derivative test. Okay, so because we know that stationary value, that's what we're trying to find. So dz over dx equals to 0. So that means 1 minus 4x squared equals to 0. So x will be equal to plus or minus negative, plus or minus 2. Right? Then what next?
Find the z.
Find z. Okay. So the question first part was to calculate the value of x for which z has a stationary value. Okay. Then after that we want to find z for what?
For the coordinate.
Huh? The first part of the question is this, right? Why do you need to find z? Okay. At this point, is the answer correct? X equals to plus or negative 2. What does the question say?
Show that this value of x.
So what's the first 3 words of the entire question in the textbook?
Positive number.
It says that x and y are 2 positive numbers. So what do we need to do? We should reject the negative one, right? So x is 2 or negative 2, we reject with negative 2. Okay, so we have answered the first part of part 2. Then after that, we want to show that this value of x makes z a minimum. What would we do to actually show that part? Will you use the first derivative or second derivative? Second derivative, right? Easier, hopefully. Okay, so that will give us 1 minus 4, negative 2, x negative 3. Okay, so the 2z over dx squared will give you 1 plus 8 over x cubed. Oh, sorry. See that again? Right?
This one is minus 4.
Alright.
This should be negative.
Yeah. Correct, right? Down here, this is actually 1 minus 4x for negative 2, 1. So for... Oh, sorry, I forgot. Alright, sorry. Okay, then what next? Show that this value of x makes z a minimum. I've got a second derivative already, then what next? Sub in the x value, right? So this is more than 0, therefore my conclusion would be okay, so we have shown that therefore it makes Z a minimum. Okay, so to show that, alright, we verified the second derivative test, which tells us that dz over dx must be equals to 0, and then also the 2z over dx squared must be more than 0. So these two, both of it must happen, that's why n. Okay, then after that, we can conclude that z is a minimum at x equals to 2. Right? Let's look at try 9. We are given a right angle triangle ABC having a base of 12 cm and a height of 5 cm. Okay, then there's a rectangle BDEF with length x cm and breadth y cm inscribed in it. So it is shown in this diagram. Okay, part 1 we want to show that the area of the rectangle is going to be 5 over 12x times 12 minus x. Okay, so we're trying to show this part, the area of this rectangle. Right? So how should we go about doing that? Okay. I mean, we know the area of rectangle just by looking at the variables that are given. That will be x times y, right? Okay. But our challenge here is that we want our answer to be in terms of x. So we need to express our y in terms of x. How should we go about doing that? Pythagoras. Pythagoras will lead you to be finding the hypotenuse, right? That doesn't seem very useful to our rectangle here. Okay, very good. We use our similar figures. Okay, so how to go about using our similar figures? What two things are similar over here?
5 over y.
What two things are similar? Which two rectangles or triangles are
The
similar?
larger triangle and EF.
Okay, the larger one, that means ABC, huh?
Yeah.
Okay, and then after EFC. Okay, so EFC is this one here. Okay, so we have this YCM over here, and then we have this 5. Alright, so we have one corresponding pair. Okay, what else do we need? We have a 12 cm. We need to know what's this, right? Okay.
12 minus x.
Okay, 12 minus x and okay, so let's try this. So y over 5 is equals to 12 minus x over 12. Right? By similar triangle properties. So since triangle ADE is similar to triangle ABC. ABC is similar to triangle EDE. EFC. Okay. In this case, we need not prove that they are going to be similar because at one glance we can tell that AA similarity would definitely be fulfilled, right? Because this will be right angle. Okay, so one angle already. Then after that, there's a common angle over here, right? So we need not prove it, but we can easily identify it. Okay? So when we need to use similar triangles, right? Usually AA similarity would tell you very easily and very quickly that the two things are going to be similar, right? So from here, okay, we would get that y is equals to 5/12 times 12 minus x, right? Okay, so we can substitute in A is equals to x times 5/12 times 12 minus x. Okay, so we get 5/12x times 12 minus x. So shown. Okay, any questions regarding this? And then in part 2, similar to previous question, calculate value of x for which A has a stationary value and show that it makes A a maximum. Okay? So what should we do first? Calculate value of x for which A has a stationary value. So we differentiate our formula over here. So dA over dx. We will use our product rule. This differentiate this. 1 plus 1/2. So upon differentiating, then what do we do next? Right here lah. So 5 minus 5/6x equals to 0. So x is equals to 6. Okay. So we have satisfied the first part of the question, finding the value of x for which A has a stationary value. Okay, then after that, to show that it's a maximum, we will do our second derivative. So this one is simple. Okay, we will get -5/6 and that is going to be less than 0. So therefore, since dA over dx equals to 0 and d2A over dx squared less than 0, A is maximum when x equals to 6. we have this diagram over here, and then after it says that it has dimensions 12 cm by 12 cm, and the width of all of this, okay, is actually x cm, right? This is actually supposed to be folded, so these are flaps, okay, that will be folded up to become a box, to create a box. Okay, so we want to find the volume of this particular box. So, how do we go about doing that? So, anybody cannot imagine this, how this box will look like?
It's a box, it's a square
So,
box, a cube box.
What do you think?
Yes.
So, a box as in like that. Okay, a box like that. Right, so what would the dimensions of this box be?
12 minus 2x.
Okay, so if I want to find out what's this one,
Hey,
this corresponds to this side, right? So that will be 12 minus 2x. Okay, so the length, the base, the width of the box will be 12 minus 2x. And then we just put in the rough opening first. Okay, likewise this part over here, this will also be 12 minus 2x. And then the height of the box will be x cm, right? So therefore the volume will be